Hello, welcome everyone. Today we are going to dive into a topic that is reshaping the future of software engineering. How Gen AI is transforming platform engineering and what it takes to adapt it meaningfully. There's a lot of hype out there, but beneath the noise lies the real opportunity to evolve platforms into something that is more adaptive, intelligent systems that sort of improves that developer productivity, reliability, and business alignment. Sometimes all of these things at once. In this session, I'll walk you through five keys to GenAI adoption in platform engineering, backed by real world proof points and a technical reference to make it as sort of actionable. My name is Ajay. I'm a platform engineering practitioner for many years and currently work for a company called Brilio, where I solve platform and product problems for many Fortune 500 companies across all industry sectors. So let's start by talking about the hype I just mentioned, right? So, as you start unpacking that current hype around Gen AI in software engineering, what we find is that over the past 18 months, we have seen an explosion of tools that claim to revolutionize developer workflows. Some of these things work well, some of them don't, right? Let's talk a little bit about that. Tools like Devin are pushing those envelope by acting as an autonomous software engineer, right? You are able to take that multi-step task like bug fixing, repo navigation, and even sort of like that end-to-end feature implementation. On the other hand, Cursor and Sweep are enhancing that developer experience by embedding LLMs directly into editors, offering real time feedback and automated refactoring suggestions. We also know that tools like Windsurf, offering that lightweight code completion in multiple languages, sort of like how you might see this in a Copilot, and auto dev agents, which sort of orchestrate that entire life cycles through the task delegation between the multiple AI agents in play. So technically speaking, this shift is sort of being fueled by three enablers, right? The first enabler in my mind is RAG, or retrieval augmented generation, which you all are familiar with. This sort of allows AI agents to ground their answers in real-time project documentation that is contextual to your organization. Second is MCP, or the Model Context Protocol. This is where we are beginning to see that emergence of standardization of how LLM agents communicate with external APIs. So these standardization can really go a long way in sort of increasing that adoption as a whole. The third one, as we are seeing this early infusion of Gen AI in things like your CI/CD, your pipelines, right? Allowing intelligent pipelines that can self-correct, tune, and suggest improvements. But the big question still remains like, isn't whether this tech is powerful, right? It's also about how to apply this responsibly and effectively within platform engineering so that your whole organization, your whole engineering organization can take advantage of it. So during the rest of the talk, we'll start thinking about some of these things. So, why Gen AI matters for platforms? So, this is something that has been a question that all of us have been asking from day one, right? Because a new technology comes in, a new fad comes in. Question is, how do I apply it? So, Gen AI has sort of shifted from that passive assistance to autonomous intent-aware agents today. You look at Devin or a Cursor or a Sweep, the things that we spoke about already. That sort of covers that. So the rise of agentic AI enables that self-healing pipelines, real-time feedback, and personalized code suggestions. So it was probably mid to late 2024. I started putting a lot more effort in understanding what that is. I'm sure that is the case with many of you. We see that that's where we are really starting to see some of those benefits of how it can actually help the platform engineering. The third one, like we spoke about, the introduction of frameworks like MCP and RAG sort of enables that integration between LLMs and platform components. So, as you can see, all three of these things have created a situation where developers are no longer the operators of things, but you're more of that supervisor, right? Within a platform engineering framework. So you're essentially augmenting that whole platform engineering with AI to sort of create that overall self-healing, overall more mature ways of doing platform engineering. So, what are these developer pain points, right? I mean, these pain points have not really changed. What has really changed is that how we sort of address these pain points. Let's take it across multiple axes. If you really look at that, journey from that pre-platform era to the platform engineering platforms era, as to a more Gen AI augmented way, and looking at across multiple axes, you find that tooling was more of that do-it-yourself in the pre-platform, which made evolved into more of those standardized. IDPs that we see today, internal developer platforms we see today, to more of those embedded AI agents that we are starting to see right now and will be the case in the next few years. Fin operations also has moved from more of that ticket-based way of doing things to more of the partial self-service to become more of that intent-based autonomous. Similarly, you can actually go through this list and you can find that every part of, whether it's a feedback or the cognitive load of the developers or the ability to remediate some of the problems or eventually that business visibility, all of these things have been impacted by an applying Gen AI. So, as you can see, this is just a natural progression, right? This is not to replace anything that somebody was doing before with something else. It is about like how do you actually elevate that game so that what you're really bringing in with the platforms are far more mature so that you as a developer, you as a platform engineer can actually focus on higher value activities. So, as we really look at this, the hypothesis I have is that there are five keys to this. The number one thing is that can we actually come up with aligning whatever we are trying to do within the Gen AI with more of those developer value streams? By this, what I mean is that if you treat Gen AI agents as flow native components, essentially like this is something that's going to help you be part of that system from its foundation as opposed to some bolt-ons, then you are able to sort of integrate these agents into literally like four canonical value streams, right? So these value streams are things that we've been talking for years, things like authoring code, testing, deploying, and fixing or remediating. So these four things are what's going to really help with your value stream. An example of this would be an agent that sort of detects some flaky tests that should live inside your CI pipeline, right? So that it can start correlating the logs and not just create an alert, right? So this would be like the real value that you could get out of it. So the second hypothesis in this case is like, can we optimize for flow and not for features, right? By that, what I mean is you avoid creating yet another dashboard or a standalone UI for AI features, right? I mean, so I've seen that some of the users, some of the companies do that. Probably instead of doing it, could you start embedding Gen AI directly into those developer workflows? By this, what I mean is it could be your dev portal extension if you're using Backstage or Cortex or something like that. Could be somewhere an extension there. Could be an IDE plugins, right? Because eventually we know that most of these portal functions and all those things could get into your actual IDE. It could also be your CLI auto responses, right? So then, and how about if we use those platform orchestration to dynamically serve AI functionality, whether it is like CI pipeline generation we spoke about or infra provisioning, uh, all these things based on the context and the role, right? So if you know that, hey, here is the kind of resources you need, instead of you telling the system, it's able to figure out what that is, and then the agents trying to drive that. The third one here would be like thinking of it like making those agents a lot more collaborative and not controlling. And this has been something that we learned a lot when we started thinking about platform as a product and the whole adoption side of things. What we are really thinking is that you have to design the agents more as to propose actions, not to enforce them. So if you are really avoiding replacing that judgment with automation, you're not going to be successful, right? The judgment, human judgment, has to be part of it. So I'm a big believer in having that human in the loop feedback loops. I'm sure you've heard and read a lot about it in the recent times. But ensuring that human in the loop feedback loops are persistent and evolvable is important. And the next thing is sort of ensuring that your enable developers are able to override, retrain, and recontextualize that agent so that overall value is higher. The fourth hypothesis is that observability and guardrails have to be there by default, right? So you're adding LLM specific observability, whether it is to token trace logs or prompt drift detection, which is a huge challenge in this case, or relevance scoring of RAG responses, because just because you have a RAG doesn't mean that that's relevant. So you need to really have some level of maturity just there. Then once you do that, you have to think about like, can we actually log those agent actions and outputs to open telemetry or something like that, right? Whatever observability platform that you would use. Once you do that, implement your guardrails like explainability, audit trails, and all that, and then the versioning will also come into play, which should continue to increase the value. So the last hypothesis I want to talk about is measuring that business impact. So you did all these things from a technology side of things. So now how are you actually going to do that impact measurement? So discard accuracy, latency latency as the only KPIs, right? Because sometimes we have been trained as platform engineers, we have been trained to think of it like, hey, you have to be accurate, you have to be to address the latency issues. But what if you start tracing those developer actions through MTTR improvements or your change failure rates, so things like that, from a DORA 4 metrics, right? Or it could even go beyond that to look at your flow index or a developer NPS and things like that. So things like your backstage, your dev portals will start exposing those metrics that matter, right? So in this case, your GenAI, you could say that, hey, my GenAI agent saved 2 hours of config writing last week across 6 teams, which translated into so much of business value. Now, once you have looked at this hypothesis, I wanted to give you a quick high-level view of what a notional architecture of something like this would be, right? I split this into about 4 zones. So first zone is again, easy enough to understand. The inputs there would be like your source code, issue tracking, and developer intent via your CLI or a portal. Your interfaces in this case would be actually developer portal or your VS Code plugins or any of those IDE plugins. And then you'll have some embedded prompt engines there. So these prompt engines could be like LangChain, CLI agents, or something like that. And your developer agents in this case would be more of those local co-pilots, which I'm sure all of you are using, or your PR assistants or pipeline suggestions. In the next plane, one of the things that next zone I would look at is what I call as this platform zone, where you're really looking at core platform services. This is your CI/CD infra provisioning, whether it's through Terraform, Pulumi, or any of those things. And you could also have your AI-aware control plane in there. So this sort of integrates your agent outputs like YAML or infra into some of the build and deploy pipelines. And this is also the place where you sort of define your golden paths, right? So you define your standardized workflows for safe AI integration there. The most interesting zone in the context of what we are talking about is what I call as the AI zone. So AI zone is where you're thinking of like some level of agentic infrastructure, right? So you have your multiple LLM powered agents, task oriented or persona bound, doesn't matter. All those things reside there. You also have your MCP, which is where you're going to have some of those standardized agent to platform communication. For example, if agent triggers a CI job, MCP carries that metadata and context for doing that. And RAG, like we talked about, retrieves the context from internal knowledge databases, right? What's the PR history? What's your platform runbooks? And make it applicable there. So the last part there is what I call as the data zone. This is where you have your centralized telemetry via open telemetry or proprietary tooling. And you have your feedback corpus, right? I mean, so you have your developer feedback, your prompt history, performance metadata, and all that. And the next one would be like once you look at that, your business intelligence layer would kick in. So this is where your platform activity gets connected to OKRs, KPIs, and product analytics. So once you look at this architecture, let's see, so we talked about those 5 hypotheses, right? Let's just sort of test that out a little bit with a few use cases. The first one I want to talk about is this idea of anomaly detection and healing in CI/CD pipelines. Right? So the problem is that you have high MTTR due to late-stage error detection or some kind of a CI/CD pipeline. So approach would be like you have some agents that's going to monitor real-time CI logs, analyze the failure signatures using embedding similarity, and sort of propose target fixes. And once it's this is proposed, the idea becomes like, okay, can we actually trigger this autonomous rollbacks or healing scripts, with developer approval gates? So the impact would be like your MTTR gets reduced, and then it sort of prevents the recurrence of this whole issue, right? This sort of proves my hypothesis case, so like for 1, 2, and 4 there. Now, if you look at the next one, something like an intent-based pipeline orchestration, the problem you might be trying to solve is that, let's say if you're using GitHub Actions or GitLab CI or something, that pipeline authoring process can be slow, error-prone, or burdens cognitive load, right? I've seen developers just copy some of the existing pipelines and trying to tweak it, that creates more problems. So the idea would be have a CLI or a form-based intent input. So I can go in and say my prompt would be something like, "Hey, I want to deploy a Node.js app with test and staging environments." And then your GenAI agent can return contextually the correct pipeline YAML, validated against the actual platform policy schemas as well as any learnings that it has had along the way. The impact would be like a significant reduction in your config authoring time. and the policies as code are enforced without any friction because you're not enforcing that after the fact. It is sort of comes out of the box. This sort of demonstrates multiple hypotheses that we spoke about earlier. Next thing would be something like your cloud resource optimization, right? If you are really looking at cloud resource optimization, the real problem is that, again, this has been there from the beginning of public cloud usage, having that oversized or idle compute resources that incur massive waste. So this, I would call this as more of that FinOps blind spots, right? I mean, that we have been talking about for years. So the approach here would be having your agent sort of ingest this telemetry to flag inefficiencies and then provide the suggestions via chatbots, developer portals, or any kind of PR patch proposals. And if you do that, you see that the impact becomes like a lot more auto right sizing as well as schedule based shutdowns. That can save 20 to 30%. In some cases, and far more in some other cases. Um, Next one would be more like some kind of an AI best practice assistance for PR agents, right? So developers keep security and architectural best practices in PRs due to time pressure. Right? So when you have a critical fix that you need to put in, you're always focused as a developer focused on the functional side of things. So you might be skipping some of these things. So what if you could actually have your GenAI agent sort of embed in IDEs or like or PR tools, and use some level of vector embeddings to match the PR content with domain specific best practices. And the impact here again is that increased standardization, right? So that upskilling sort of happens during that review, and then the seamline inline suggestions with explainability that's provided by your contextually specific RAG can create that huge impact there. The next one would be the next like proof that you might want to really look at it is something like, how do you sort of surface this business impact to developers? Developers don't see a lot of these things affect customer or business outcomes, right? I mean, so they are sort of insulated in their own way. So if you were to take an approach where you link your commits, pipelines, and feature toggles to your OKR dashboards, we have been talking about it for a while now. Things like your end-to-end system observability kind of thing. Your AI agents can then summarize that impact, right? You can say that, hey, this particular PR contributed to 5% reduction in sign-up time or your onboarding time, any of that. So that would be a huge business impact that you can see right off the bat, which all leads to that higher engagement, satisfaction, and ownership, and sort of informs that prioritization and trade-offs with business alignment. So as we talked about a lot of these things, so these five, if you were to take these hypotheses and sort of test that out within your environment, you would find that there is significant value in really applying AI in a more practical way. If you are more interested in talking about this topic, you can reach me at this email and all the other coordinates here. I've also recently published a book together with a few of my fantastic co-authors. And feel free to check out this book. There's a QR code here. You can actually check it out, and you can also get discount codes by reaching out to me. And I'm talking about a lot of these ideas within that book. So thank you so much, and hope you enjoyed this presentation.